Welcome everyone. I heartily welcome you to Math Simplified by HM. Today we are decoding sequences to show you how math is filled with elegant, predictable patterns. Think about how we use numbers like 1, 2, 3, and 4. Their specific order allows us to identify their exact position instantly. In mathematics, any set of numbers arranged in such a definite order is known as sequence. Whether it's a natural numbers or students standing in a row, the order matters. We identify these positions as terms. A1 for the first, A2 for the second, and An for the nth place. We are about to decode the mathematical rules behind these patterns. But first, ensure you subscribe to the channel and hit the bell icon. Don't forget to like and share this session with your well-wishers. Grab your notebook, feel free to pause as needed, and let us dive in. The pattern decoder, demystifying the mathematics of sequences. Humans are wired for patterns, from students standing in a neatly ordered row on a playground to the sprawling petals of flower. We intuitively recognize predictable order. Students standing in row, some geometrical shapes, and boxes arranged in a row and column. Mathematics is just the language we use to decode them. Here the balls are increasing, here triangles are increasing. We can see the shapes growing, but how do we predict what comes next without drawing them forever? Translation visualization from shapes to numbers. The index, the data. First term 5, second term 8, third term 11. This gives us fourth term as 14, fifth term as 17. By separating where we are looking the position from what is there, the value, we create an ordered list. Now defining the sequence. A sequence is a set of numbers where the numbers are arranged in a definite predictable order. The benchmark of order, natural number n, curly bracket 1, 2, 3, 4, etc. on a line. The language of sequence. We can map sequence terms T1, T2, T3, Tn on a line. We call this as the term locator map. The letter n is not just an algebra variable. It is a GPS coordinate. It tells us the exact address of a term on the sequence timeline. The rule bridge. Here 1 plus 3 gives 4, 4 plus 3 gives 7, 7 plus 3 gives 10. So next term will be 10 plus 3 is equal to 30. Thus, a mathematical sequence is driven by a constant repeating motor. Here motor is plus 3. To find the next term, we just follow the bridge. Uncovering hidden motors. Here 100 minus 30 gives 70, 70 minus 30 gives 40, 40 minus 30 gives 10, 10 minus 30 will give us minus 20. In second example, 4 into 4 gives 16, 16 into 4 gives 64, 64 into 4 gives 256. Thus, the rule can be an addition, a subtraction, or a multiplication. The only requirement is absolute consistency. The sequence taxonomy matrix. Sequence type. Example, the rule predictability. Arithmetic progression 1, 4, 7, 10. The rule add, subtract a constant. Highly predictable. Geometric progression 4, 6, 64. Multiply by constant. Highly predictable. Random set 2, 11, minus 6, 0. There is no rule and unpredictable. The anatomy of a sequence. Tn plus 1 term minus Tn term gives us the constant difference d. The next position, the destination is Tn plus 1, and the current position, the anchor, is Tn. Then Tn plus 1 minus Tn is equal to d, the common difference, the motor or the rule. An arithmetic progression is simply a predictable journey if the difference d between consecutive steps remains constant. You can predict any future destination. Thanks all. To wrap up our session on decoding sequence, now we know that terms are written as T1, T2, T3, Tn, and the entire sequence is denoted by Tn. This relates to our real life. Success is not a single jump, it is a sequence of small, consistent steps. The key takeaway is that an infinite sequence, every single positive integer n has its own unique term Tn. The pattern never truly ends. I hope you enjoyed simplifying math with me today. Please like this video and share it with everyone who might find it useful. Hit that subscribe button and the bell icon so you never miss a lesson. Enjoy the great time and keep practicing those patterns.